So before we proceed to the rifle demo, I also wanted to explain the importance of components and the assembly and basically testing your joints. I'm only gonna lightly touch up on the topic because it's not as important, but nevertheless it's good to know. So in order to do any animation testing or movement testing, basically whenever you need to test your design and functionality, it's just good to use the joint system in Fusion 360. It's in the Assemble tab right here. And I'm going to explain the as-built joint and the regular joint options. And then you definitely feel free to explore the rest on your own. It's not as complex as you think. Basically, in order to start this, you need to define your components. Components, you can think of them as the modules that I was mentioning previously. So parts that make sense together. For example, this body right here is going to be our component 1, and this body right here is going to be our component number 2, and I want this component number 2 to be rotating around this part, and this would be our center of action. We're actually just going to add a cylinder to define that joint, because in reality you would need to be building that joint using something else. They cannot be just next to each other and then they won't be able to rotate. Just gonna keep it here. We're not gonna cut it. Just to exaggerate, this is what it's gonna be like. And then of course, just like I was mentioning before, complexity only where it's needed. In terms of the making this magic happen, you don't really have to make the opening right here like this. So like if I had a height body number 5, it connected. Hold on, let's go back. Let's redo the cylinder one more time. So as I'm building this cylinder, I'm not going to join it, move it in. This is going to be the center of our rotation. So in order for this to rotate, we don't have to actually make the opening. This part doesn't have to have the cut. Oops. This part doesn't have to have the cut. So if we hide it, we don't need this opening at all. That's just extra geometry. You will never be able to see it unless you're going for something like this, where it needs to be very obvious that this is how the parts are connecting. So in that case, yes, maybe it makes sense. Even then, maybe not all the way through. Because for concept, that's just, you're going to be retopologizing it later. It doesn't matter. But anyway, what we're going to do is we're going to take this body and this, and we're going to merge it together. And this is going to belong to one component like this. And what we need, you can think of components as technically like just folders. Where we're going to take this body, right click, create component from bodies, and now this is going to be a component, and then create component from the other body. So we have 2 components now. A little trick to make it more clear visually, in the inspect section, go to component color cycling toggle, and this way you will have every component at a different color. One neat little trick with components is that you can, like, one of the reasons why you would want a component is you can right click it, save a copy as, and it's gonna create a separate file in your Fusion folder. So let's say you built the whole rifle, and then you just take all the bodies that belong to the scope, drop them into the separate component, and then you can save that scope separately and reuse it. It's super convenient. So now that we have two components, now we can go into the assemble and try and create a joint. The first type of joint is going to be as built joint, means that it's already in place. We already built it the way it's supposed to connect. So we're going to pick, this is component number 1, this is component number 2. It just jiggled to show that we chose the rigid type. We actually need the revolving type. And we will need to define the center of rotation. This is why we need that cylinder. We technically didn't need it, because even if we don't have the cylinder, if this is like a cylindrical joint, you will be able to find the center of rotation without it, but this is just a lot easier. So I just clicked it and it started rotating because it's previewing the animation right here. And this is literally the part where this is why we need this animation. You can see that the red part is intersecting with the blue. And this layer of believability that we add would be that let's make it look like it's not actually intersecting, it's not crossing. So how do we do that? Well, first of all, we're gonna do a combine, and this body and this body, we're gonna make a cut, keep the tools, and say okay. So now when we hide the red component, you can see that we created this cut that accommodates, this is like a new design feature, right? Something that you didn't think about before. Now that we have it, we know it's needed. This is why a lot of parts, like mechanical parts, engineering parts, look the way they look, because they are required to have a certain shape. But as you can tell, this only accommodates for the rigid joint, for the position. So in order to fully sell the idea, we will need to rotate this red part. We're going to set the pivot to the center, and see, look at the way, let's reduce real quick. Look at the way the red part is traveling. It's making this movement. So we will need to get rid of all of that. And the easiest way is to just make a cut, keeping in mind some of the tolerances. So maybe about this far, just give it a little bit of a tolerance. Just use it as a new body. Make sure it goes past everything that we need to cut, and then make the cut. Don't need to keep the tools. So now that, and that's not even enough, because I'm predicting that the red part is going to start moving. Well, it's barely doing okay. You can see that at a certain angle, it's still touching the very bottom end, so we're gonna have to adjust it and move it down to accommodate for that swing. And somewhere here is gonna be just enough. And then we're gonna hide the red part and just make the design look or read better. Make it look like it's actually been, people been thinking about it, not just making a cut. Something like that will do. And this is how our part now has this very specific, unique look, because it accommodates for that movement, including that tolerance. We'll probably need to bring this back. And now we're not going to go back to as built joint because we can clearly see that it's going to rotate and it's not going to interfere with anything. But a lot of times you want to build that separately somewhere else. So for example, you can build this red part on the side like this, and then build this. It's rarely makes sense because it's easier to do a as built joint. But as an example, you do the regular joint. You're gonna point to first to the component right here. Then the next component is this one. You basically wanna put the flag in the center of that rotation, in the center of that joint. It doesn't have to be rotation. It can be rigid, like this. We already have a joint, so you can see that this is how it connected. Let's do it the other way around. Let's start with the other part. This is going to be 1. This is going to be 2. There you go. Beautiful. We can play the animation, and we know that this is a working, well, too close. Let's move this component. Let's stop it, and the second component needs to go probably here. It cannot be here, right? Because it's intersecting again. So this is our original as built with a slightly more tolerance. Play it back. Great. We have a working mechanism now. And obviously lots of types of joints: rigid, revolution one, slider, cylindrical, pin slot, planar, ball joint. You're welcome to explore them, but this is the basics of how joints work, and this is exactly how you test your design and function. Just as far as joints go. So we're gonna go ahead for the next chapter and model the rifle.